This is geometry 6.3. We're talking about standard position. We're going to be putting a polygon in standard position on our coordinate plane, and we'll be able to do coordinate proofs using the midpoint, the slope, and the distance formula to prove different facts about shapes. When we begin coordinate proofs, we'll need to be able to place figure in the coordinate plane in a standard position. Okay, for the most part, we are in quadrant 1. This means that we want to place one coordinate at the origin. That's a fact. Okay, we're always going to have a point at the origin. And we'll want to minimize the variables that we're using. And we'll talk about that. So here we're going to place a figure in the coordinate plane in a way that is convenient for finding the side lengths. So we're going to talk about a square first. So as we've stated, we're going to put a vertex at the origin. So we know that that location is going to be called 0, 0. And we're going to lay this square in quadrant 1. So we're going to place another point over here. Now, we're not sure how long this is, so we're not going to call it 3, we're not going to call it 8, or anything like that. We're going to call it A. It's a distance to the side, to the right, so it's positive. It's an x value, so it's first in our coordinate. The y value, since this is touching the x-axis, the y value has to be 0. So anything on the x-axis is going to be an x value, comma, a 0, because it's up and down 0. Now, if this is going to be a square, we know that this length has to be the same as this length. So we'll approximate that location out here. If this is a length of A, then this it has to be a length of A, because that's true about a square. The side lengths are the same. So it's 0 right and left, but it's A going up. Now for the fourth point, we know that a square has these right angles. So what is this location going to be? One of the things you want to think about, is it required to be a specific value? If we put a vertex at the origin, a vertex on the corner, another vertex here on the side on each axis, what would this be? What's the coordinate that this has to be? It's going to be the same distance over, because that's true about any of the parallelograms. The opposite sides are congruent. So we know that we're going to be directly above this vertex, and we're going to be directly over from this vertex. So we're going to be at the same height as this one. So that has to be A, comma A. That way we're certain to have a right angle because we're straight up. We're straight over, so it's a right angle. So that's forcing us to have right angles since we're at the same height as the A and we're at the same distance as the A. So here we could talk about how we would have 4 congruent sides. We could do some calculations to talk about why the angles are right angles. We should have opposite reciprocal slopes. We might even be able to do some distances with our diagonals. All the facts that happen, we can do those just with these coordinates. That would represent any square with numbers we can represent with a single set of letters. Here's a rectangle. Well, we know we're going to put a vertex at the origin. We're going to put another vertex along the x-axis. Doesn't really matter where you place it. I'll place mine right there. That distance, we typically call it a comma 0. Now think about a rectangle. Is there a certain height I have to be for this to become a rectangle, or for this not to be a rectangle? Does it have to be the same length as A? Does it have to be twice as long as A? Does it have to be shorter? Does it have to be longer? Or do we have several choices to make?
Still, it's like not like longer than the set, so it's not like a square.
All right, so we don't want it to necessarily be the same length as the A. Okay, it could still be a rectangle with that, but it doesn't have to be the same as the A. So let's do something different than A. Let's come up here and call that B. That's a different distance than the A. Because in a rectangle, the consecutive sides do not have to be the same length. So I can use different variables to represent that they don't have to be the same. Now, what about this final point? Is there a specific location where this final point has to be to ensure that we have a rectangle? Or can it be most anywhere we want? If we put a vertex at the origin and on each axis, is this one required to be somewhere special? We think about this rectangle and we place it here. This point would have to be right here. There's really no other option. So what is this coordinate going to be? How far over is that coordinate, and how far up is that coordinate? A, comma, how far up would this side have to be? Same as the B. So there's our rectangle. Okay, those are supposed to be the easy ones. Now we'll get into some interesting ones. How about an isosceles triangle? Do you know about an isosceles triangle? Isosceles triangle has at least 2 sides the same. So we know we're going to have a vertex at the origin. We're going to have this point out here. Now this is where life gets a little confusing. We typically call that point A. That's what we did for our rectangle. That's what we did for our square. But because we're aware of how some of our other points are going to line up here, it might be more convenient for us to call this 2A. 2A comma 0. Now let's think about our isosceles triangle. To be an isosceles triangle, where does that third point have to land? Of course, we could probably place that isosceles, create an isosceles triangle by putting a point on our y-axis up a length of 2a, and then we'd have two sides the same. That would work. But that would require us to have this right angle. Every isosceles triangle is not required to have a right angle. So let's not put it on the y-axis. So if it's not going to be on the y-axis, this magic point is going to be halfway in between 0 and 2a. So this distance here is going to be a. So instead of calling this a, and that would be half of the a, if we call that 2a, then we can call this half of the 2a, which is much easier to be written as just a. Is there a specific height we have to be on to be an isosceles triangle? For these two to be the same length, do we have to be up a special height? We could be up any height and those two lengths are going to be the same. Any height allows us to use a different variable, because there is no requirement about exactly what height we're going to be. That's making this a perpendicular bisector, so these two sides are the same. It's being cut in half. This side's being cut in half. If a point is on the perpendicular bisector of a segment, then what's going to happen? This point here is on the perpendicular bisector. It's on this dashed line. So anything on this dashed line is equal distance to the endpoints. Then it's equidistant to the endpoints of that segment. Okay, so this would be our standard position of an isosceles triangle. We're over an amount that we can easily take half of, because this vertex is going to be, the x value is half this length, and it's up any amount we need it to be. Doesn't have to be at a certain location related to the a. Let's try an equilateral triangle. Equilateral triangle is going to mean that all the sides are the same. So we're going to have a vertex at the origin. We're going to have a point out here. We're going to, again, call it 2a, because we're going to be interested in this distance that is in between the 0 and the 2a. That distance is a. So, if this is 2a, what do we suspect this side to be? If this is 2a, and this is an equilateral triangle, what length is this? 2a. It's got to be the same. And this side has to be the same. So, is this height at a special spot, or can it be anywhere? It has to be a special spot, because we were saying here, if this was 2a, the height could have been anywhere, and we still would have been equal distance to the endpoints. But here, for these sides to match this one exactly, it has to be at a special location. We know the a value is going to be a. It's going to be half what this side length is. We're cutting it in half. We're going straight up. The question is, how high up do we go? So here we have this right triangle. You're going to learn more about this right triangle in the future. This is a perpendicular bisector, so you know that it's a right angle. It goes straight up to find this location. This length is cut in half, so it's going to be a. We said that the side length was 2a. So now we can calculate what this height is here. What that y value is. Any suggestions how we would figure out what that height is? We could use Pythagorean theorem. So we could use hypotenuse squared equals leg squared plus leg squared. So this is 4a squared. When you square the 2, you get 4. When you square the a, you get a squared. 2a times 2a is 4a squared. We're going to subtract over our a squared. That doesn't cross the a squareds out, but it is 4a squared minus 1a squared gives us 3a squared. And then we take the square root. We're not worried about plus or minus because we're talking about geometry. So this is a length. So we're only talking about the positive length of this radical. How can we take the square root of 3a squared? Can you take the square root of either of those numbers? Can you take the square root of 3? No, we're not familiar with that. Square root of 4 is 2, but I don't know what the square root of 3 is. How about a squared? What times what makes a squared? A times a makes a squared. So you can take the square root of a squared. So we have a root 3. So that's what that height is. A root 3. So this has to be a square root of 3. If that's the height of our triangle, then we're going to create exactly an isosceles actually an equilateral triangle. A scalene triangle. A scalene triangle, again, we're at 0, 0. We have a point out here at A, comma 0. We don't need this midpoint this time, so we can just use A. It's not really important for it to be right down the center. We don't need to know that location. So we're just going to use A. Now a third point. To make this a triangle with no equal sides, does this third point have to be anywhere special? Just not right in the middle. So it's going to be over a distance of B and it's going to be up a distance of C. There's no relationship to the A or the B for what that height is. So that's our scalene triangle. No sides are equal. No angles will be equal. You could have a right angle, that's true, but it doesn't have to be. An isosceles trapezoid. This gets a little complicated looking. We're going to have 0, 0. We're going to be out here at A, comma 0. Now let's think about what this shape looks like. This is an isosceles trapezoid. So when you're making a trapezoid, this point here really can be any distance over. There's no requirement to exactly what that length is compared to the base. So we're going to call that B. Because this distance here is B. The distance up is going to be C. There's no requirement for how tall isosceles trapezoid has to be. But once we place that location, this one has to be at a specific location. This triangle that's being formed here has to be mimicked right there. They have to be the same triangle. For this to come out to be isosceles, these two triangles have to be the same. So this portion has to be B, and this height still has to be C. So I know my height is going to be C, but what is this coordinate going to be right here? If it was D, then it could be just something different than the other ones. But it's going to be all the way over to A, backed up this distance of B. All the way over to A, and backed up this B distance. And that's going to make it equivalent to that. So it's A minus B. Little complicated there. This spot is very important for it to come out to be an isosceles trapezoid. So last thing we're looking at. Place a rectangle in the coordinate plane so its vertical sides has a length of A and its horizontal sides has a width of 2A. What does that mean? Vertical sides have a length of A. Vertical sides. So this has to be 0, comma A. Then we're going to make our rectangle. The horizontal side length is going to be twice that length. It's going to be 2a. And since you're right on the x-axis, the y value has to be 0. So what is this final coordinate going to be? If this is a rectangle, you know that a rectangle is straight up, and here it's straight over. So it's at the same height as this point, and it's at the same width as that point. So what's our coordinate going to be? 2a, because it's the same distance over, and the same distance up puts it at a. There it is. So our next step would be to find the lengths, to find the slopes, to find the diagonal lengths. We can show a lot of facts about these shapes. Good job, everybody.